increasing the heavily health infrastructure in Saudi Arabia. So should be tackled, and within food security, effective food security programs in Saudi Arabia. Also, absence of infrastructure for data collection, for epidemiological study, and also for other food intake and consumption studies. Compliance on lifestyle changes for food waste, segregation, and other awareness programs, which should be change the perceptions of the population in Saudi Arabia. Fidelity and evaluation of food and nutrition programs should be also implemented to have an effective awareness programs. In the part of private sector, we have high cost, time, and reputation and taste challenges on food production for the private sector, which should be tackled with the private sector side. In terms of food labeling, traffic light labeling, and all of this stuff, and also changing the labels, which cost a lot for the companies. Absence of healthy food environment, which is we should work on it a lot to change the perceptions of population. If it doesn't work, the environment will help us, which is a lot of choices, healthy food choices with the cheaper prices will be present in front of the consumers. Trade obstacles with World Trade Organization members, which is a lot of issues actually we face in Saudi Food and Drug Authority and other authorities and other ministries like MIWA. In changing standards to healthier food items and safe items. Absence of harmonization, maybe I give this point, absence of harmonization between government sectors in regard to projects to unify the methodologies and ways of R&Ds and intervention programs. This is the last point what I have summarized. Thank you so much.
Thank you. And our other chair from yesterday, Princess Mashael, had run a very tight ship actually in her session around environmental change and the Saudi Green Initiative. So Princess Mashael, if we could please have you to the stage to provide a 2-minute summary of your session.
I hope I'll be able to be as brief as my speakers were yesterday. So essentially, we had a very interesting session yesterday. I tried to sort of steer it in a specific direction, starting with the climate science first, then threats to food and trade security, metrics and indices, reimagining an operating model where there's a partnership between the public and the planet, and last but definitely not least, wrapping up the relevance of our flagship SGI targets of tree plantation Saudi Arabia with food security. So Professor Ibrahim Khaled focused on regional climate change and food security in Saudi Arabia, looking at projections that are international and trying to see within the models how could we project something that's a bit more local. Professor Kenneth Stresbeck spoke about the threats of food trade security in Saudi Arabia, and specifically on some of the main threats that he's mentioned were on the pandemic, maritime shipping, conflict, and climate change, how that could be having a multiplier effect, in addition to seeking ways of developing a global food trade vulnerability index within the current conditions. Dr. Mari Rwami spoke about indicators of climate and food security in Saudi Arabia, and talking about it through 3 main dimensions. One is on domestic sustainability, the other is on adaptation and resilience, and the third is on import security and sustainability, as well as a very important cross-cutting dimension that maybe not a lot of people in this room speak of, which is the political commitment to climate action, or let's say the geopolitical hat. Masreen Al-Alemi spoke about what it would be like, or how could you envision a public-planet partnership, and sort of started to put the beginning of semblances of how that could be successful and how could you use that as a tool to fund some of these ambitious projects. And definitely Dr. Khaled Abdul Qadir wrapped us up with a very positive message on the SGI targets and its relevance, but specifically seeing equally the opportunities or the key challenges within the environmental sector. I think for me, there were three key reflections, if you allow me that. The first is the importance of accounting for the unknowns and the unknowables. Saudi has emerged quite resilient post-COVID, but we were that because we had long-term investments in the health sector, we had very solid public services, and most importantly, insights. Insights that were there because of MERS outbreak that happened a few years back, and even more importantly, because of H.R.H. So those kinds of insights are quite specific and allowed us to account for things that might not have been seen in the horizon, which is a major outbreak on a global level. So we have to be thinking of what are we not thinking about. The second is the importance of homegrown research in the sciences, both basic and applied. No one, I think, in my opinion, will do the research that's in line with our cultural values, our ability to deploy lessons from our past, because I think that there's so much that we can remember and recall from our past, as well as where we place important at the granularity that's needed for the decision maker. So we cannot rely, for example, on the IPCC and their hexagons to come up with the climate models that are relevant, or on this aggregated data on agriculture to let us know how food trade happens on a global level. We need something that's a bit more granular, that goes back to the point on data. And last but not least, I think that's the hat that I constantly wear, is the importance of thinking really seriously about climate change and its multiplier effect. Anything we solve for will be a lot more complicated in a changing climate. So, but equally, I think there's a huge opportunity. Saudi Arabia last year came up with the Saudi Green Initiative. It has a major commitment to neutrality by 2060, as well as plans to plant trees, 10 billion of which are within Saudi Arabia. The other 40 billion will be around our region. So I think this gives us a novel and a unique opportunity for having multiple wins. Food security, carbon management, the betterment of our soil, and hopefully, I think, as a beacon that KAUST has been, and hopefully the rest of Saudi Arabia will follow suit, novel innovations from Saudi Arabia to the world. So this is my hopefully short enough wrap up. Thank you.
Okay, thank you to the chairs really for setting the scene for day two, which I think will be a really fun day today. We're going to hear about some very clever and innovative solutions that are being developed right here. I hope you leave today with a great sense of optimism around the future of food security for the kingdom and how we can meet these challenges. We have two plenary sessions to begin with today, followed by focus sessions where we will break into groups, and then you will either go into some breakout sessions, which will really be working groups, and they're invitation only still, or there are also going to be some tours of some of the impressive research and commercialization facilities around KAUST. So that's later in the day. But to begin with, we have a plenary session on the future of alternative proteins in the Saudi Arabia. So the consumption of alternative proteins is increasing very rapidly around the world as consumers choose to reduce their animal meat consumption. To help us understand this opportunity, we have a team of experts to provide us with an overview of the alternative protein industry with a specific case study and role this industry might have in food security in Saudi Arabia. So to start with, we have David Welch, who's going to come and talk to us about the plant-based protein industry. I'm going to explain my time management technique to the speakers. Okay, so in this session, I will give you a 1-minute warning. Right, that's 1 minute to go. Once you hit time, I'm going to stand up from my chair so you know it's time. If after about 30 seconds you still keep talking, I'm going to slowly and in a rather predatory manner approach you at the stage. And if I'm standing next to you, it's time to finish, okay, at that point. All right, so that's my time management method. Okay, so David Welch is our first speaker. He is the Chief Scientific Officer and co-founder at Synthesis Capital, a new investment management created to transform our food industry through food technology. He was previously Director of Science and Technology at the Global Food Institute, the Good Food Institute, where he helped startups, invested corporations and universities accelerate the development, scale up and commercialization of alternative protein technology. So he is really very well placed today to give us an understanding and an overview of this industry. Will you please welcome David Welch?
Thank you. Hopefully everyone can hear me. Let me share my screen. So hopefully everyone can see that. Please let me know if you can't. First, I'd like to thank you for those kind words, and also thank Mark Tester and the other organizers for the opportunity to speak to you today. And my apologies for not being able to be there in person. What I'd like to talk to you about today are some of the technologies that I'm seeing that are converging together to transform our food system, and that I believe will create a more robust and secure food system in the future. And to set the stage, I'd like to start by highlighting some of the challenges we're seeing with our current food system. First, as a planet, we get an increasing amount of our protein from animals. As people around the world have more disposable income, they tend to eat more meat. And this, combined with a rapidly growing population, really shows a continuing increased demand for meat. And in general, what we see is that animals are not the most efficient source of protein for a growing planet. If we take the chicken, for example, this requires 8 calories of energy in to produce just 1 calorie of food for us, so a 13% conversion efficiency. And the cow, as you can see, is significantly worse at a 3% conversion efficiency. And this requires us to dedicate a large amount of land to grain production for animal feed and land for rearing animals, which diverts resources from more efficient food production processes and really contributes to food insecurity around the world. And more broadly, if we take a look at how the food we produce and eat today impacts our planet, I think it's clear that our current food system is really broken and having a devastating impact on our planet. And that ranges from greenhouse gas emissions to the amount of the world's habitable land that we use for agriculture, to the impact on global freshwater withdrawals and global eutrophication. And it's really having a decimating impact on biodiversity as well, as you can see from this slide. But fortunately, and what I'm here to talk to you about today, is that we're now seeing a convergence of technologies that's creating a paradigm shift in our food system and the way we grow food. And this paradigm shift is really the result of 3 primary waves of innovation that have happened over the past 50 plus years. The first wave, the Green Revolution, brought about the first changes in the way we grow plants and animals, dramatically increasing the production limits of crops grown for both food and animal feed. And then the second wave brought digital innovations to agriculture to drive these production efficiencies even more. Automation and precision agriculture are examples of these. And then in parallel, we've had these incredible breakthroughs in modern biotechnology, 3D printing, tissue engineering, even the mRNA vaccines that we're all very familiar with now, have allowed the development of therapies and cures that really weren't possible just a decade ago. And these technologies are now converging to transform how we produce these foods, meat, egg, and dairy products that people around the world really want to eat and like to eat. And these enabling technologies, such as gene editing, machine learning, synthetic biology, and food science, are really converging together to catapult this food system forward, ultimately giving us better processing methods, better crops, and other source materials designed specifically to produce meat, egg, and dairy products that taste great, hopefully, nutritionally optimal, and really available to everyone around the planet. So in essence, what we're building, or what we're starting to build, is a bigger toolbox to accelerate a transformation. And this transformation is happening within 3 technology verticals: plant-based, cultivated, and fermentation. And briefly, plant-based is the use of crops to biomimic animal meat, egg, and dairy products. And certainly, as I'm sure you've seen, this category is the most mature, and there are many products on the market. But I think there's still significant white space remaining to develop better crops, better ingredients from those crops, and better manufacturing technologies to produce better tasting products. Cultivated, this is the use of stem cell biology and tissue engineering from the cell therapy space to create real animal meat and dairy products. And it's certainly the furthest away from commercial reality, but we're now starting to see multiple companies in many parts of the world build pilot scale facilities and dramatically lower the cost of the raw materials they use to create these products and the end products they're creating as well. And then last but not least is fermentation, the use of microbes as factories to produce protein biomass and individual ingredients such as hemoglobin and casein. And this is a very scalable technology, which I'm sure you're aware of, that's already proven in many sectors such as biopharma. And companies in this space are really pushing the boundaries of what's possible, using enabling technologies like synthetic biology and computational biology to improve the production efficiencies of these microbes, improve bioprocesses to really drive down the cost of these ingredients. And we'll hear more about fermentation in the next talk. And these advances that we're seeing in these technology verticals really have the potential to disrupt this $3 trillion conventional animal meat, egg, and dairy industry. And this obviously has analysts forecasting significant market share gain, which you can see captured on this slide here, with some of the more optimistic outlooks predicting over 30% market share by 2035. But I think what's also exciting about this is that these enabling technologies I've spoken about go beyond just the ability to create food ingredients. And they really allow us to create or enable a circular bioeconomy where plants, microbes, and animal cells that you can see at the bottom of this slide can be used to create food, but also non-food materials. And the side streams from every process can be harnessed as a fuel or a starting material for another process. And I wanted to end my brief talk here with an example of a company in Synthesis Capital's portfolio that is applying fermentation technology in a novel way that will support a circular bioeconomy just like this. This company is Archeon Biotechnologies. It's an Austrian company, a very young company, but using unique strains of the microorganism Archaea that consume carbon dioxide and hydrogen as their primary fuel source. So rather than having to grow fields of sugarcane for glucose, Archeon can use side streams from other industries as its primary carbon source. And these microorganisms will then produce a single cell protein that can serve as a complete nutrient source in a range of different food products, from meat to pasta to bread, etc. But what's interesting is that these microorganisms also secrete all 20 essential amino acids, which can then be used as raw materials by food companies or even as inputs into products like cell culture media. And I think what's even more exciting is the company plans to take these amino acids, these building blocks, and assemble them as functional peptides, which initially they'll use to improve the flavor and texture of alternative protein products. But you can imagine many other applications for these types of functional peptides. And ultimately, once at scale, this will allow Archeon to produce amino acids at less than 2 times the current production price, to feed 100 adults per square meter of land using just conventional bioreactors, all the time while using 1.5 kilos of carbon dioxide for each kilo of amino acids produced. So that was a brief talk, but hopefully I've given you a glimpse into what's possible with this convergence of enabling technologies that are being applied to our food system. With that, I'd like to say thank you for listening.
Next speaker is Mr. David Brandis. He is CEO of Planetary, a Swiss-based alternative protein infrastructure provider. They are looking for opportunities to build bioprocessing capacity globally in order to produce protein at scale without animals involved. So David, over to you.
Excellent. Thank you. So with the KAUST Center for Desert Agriculture here in the room, the Ministry of Environment, Water and Agriculture, the Makkah and the Saudi Green Initiative, and the folks of NEOM, I think it's really the best place to find the solutions, as we said, to feed the world without destroying it. If not here, where then? So in this sense, I'm happy to contribute by further elaborating on what also David Welch already talked about, the power of alternative proteins. I will try to provide a little bit of a practical perspective on the subject by really showcasing a case study of how an applied solution could look like in Saudi Arabia. So with that, let's get started. So also I'm thankful for the invitation here today by the organizers, by the sponsors, and specifically also David Welch, who already covered a couple of points here of this presentation going forward. So I don't have to speak through it and can hopefully make up for some time, which maybe the organizers will be happy about. So what are alternative proteins and why do we need them? How does the local context for Saudi Arabia look like? And how could a vision for Saudi Arabia in 2030 play out? That's what I would like to cover today. Again, part of this impact perspective has already been covered. So sustainable proteins are more effective in converting a protein into a consumer product than the animal is, right? And we'll get into that a bit more in detail over the course of the presentation. We also know that up to 15% of the total greenhouse gas emissions today are emitted by animal livestock farming, which is, by the way, more than all units and means of transportation together globally. And these feed conversion rates, I think that's also what David talked about, are particularly staggering. So the caloric conversion of beef and chicken is between, for the case of chicken, 4.5 to 1. For the case of beef, 25 to 1, which is just a showcase, I think, of the inefficiency of the animal as a calorie converter into a food product. Now, in Saudi Arabia, we learned yesterday that 80% of the overall protein is being imported. And also, we found out that Saudi Arabia is the second largest importer of chicken, frozen chicken actually, globally in 2020. So quite a staggering figure. Chicken is by far the most consumed meat source in Saudi Arabia. So I thought, let's focus a little bit on the chicken during that presentation, because it is imported quite a lot and it's definitely also consumed largely. But also, Saudi Arabia is the largest consumer of red meat in the GCC. And it's a staggering industry reaching $10 billion soon. David previously covered plant-based, fermentation-based, and cultivated protein sources. Just to put them into perspective of what that means in terms of global market opportunity, I think this kind of stacked bar chart shows it quite well. Plant-based meats is the largest share of proteins, also from a 2035 perspective. But fermentation and cultivated meats are growing steadily and at a fast rate. Today, we will focus a lot on fermentation, and I'll talk about why. But the vision is really that by 2035, 10 to 20% of all protein consumed will be non-animal based, so alternative. And I'm gonna go faster here in order to spend more time on what really matters. We will focus on fermented food sources or fermented protein in this talk. The reason is that the feedstock that is used in order to produce fermented protein. So the fermented protein means you take microbes such as Fusarium, which is a fungus, or Pichia pistoris, which is a yeast organism, and you put that in fermenters. So those are bioreactors up to 27 meters high, 200,000 liters big, and then you grow those organisms and you harvest them at the end. In order to grow, those organisms need to consume sugar, and that sugar can be largely produced locally. Doesn't have to be, but can be, and that's the beauty of fermentation. So just a little showcase here. If you want to make 200 kilograms of meat, which is roughly 1 cow, then you need 3 years of growing time. It produces around 3 tons of CO2 emissions. A cow eats over its lifetime up to 9 tons of grains and roughages, consumes 3 million liter water. That's both for irrigation of the feed and for the drinks of the cow, and that breaking down for 1 kilogram equates to 15,000 liter of water. Now, if you were to produce 200,000, so the same 200 kilograms, so the same amount of protein through fermentation, you need 18 minutes of growing time. You do need some energy, so 0.1 megawatt hours of energy. You need glucose, so that's the carbon source, 0.1 tons of glucose, 80,000 liters of water, and that only equates to 400 liters of water for 1 kilogram, meaning it's a 97.4% reduction of resources versus the livestock product. And for chicken, that would mean 96.3. So it's actually not that much of a difference, just because the fermented resource use is so low. Now, if you were to look at that from a national perspective, you could say, okay, 18 minutes growing time. We definitely have the time. We have also the energy, right? So it requires probably the setup of solar panels to produce the energy. You might want to import the glucose, for example, from Philippines and Egypt. I think it was a very interesting statement earlier on and yesterday that food security does not mean producing everything in country, but only where it makes sense. So in this case, glucose and also sucrose is being produced largely. I hear Egypt is putting up some new refineries, but also Philippines. The water use basically is what's needed to grow the glucose. So you don't actually import the water, but it goes into the glucose. So if you were now to replicate 5% of the Saudi Arabian chicken production, that means 75,000 tons of fermented protein. You need around 40 football pitches of solar energy, but you would reduce 600,000 tons of CO2. You would save 0.6 cube kilometers of water, and you would increase by 10% the in-country poultry or poultry alternative production. Also, from an economical perspective, it makes sense. In order to now produce 75,000 tons of protein per year, which is 5% of chicken consumed in Saudi, you need to install 6 times 200,000 liter fermenters, those 27 meter high fermenters. It costs around 110 million US dollars. You need around 20,000 square meters for the plant. But the revenue potential and the profit margin is also clearly there, with up to 600 million US dollar at a 30% EBITDA margin. So it's really, I think, a business model that is great for the planet, and this is what's beautiful around alternative proteins. So if I can close on the vision for Saudi Arabia by 2030, we might adapt to a 10% fermentation-based alternative protein strategy, boost the economy while saving the planet, drop greenhouse gas emissions massively by 30%, and feed the population sustainably. For example, starting in largely populated areas such as Riyadh, Jeddah, and Neom in the future. So with that, Planetary, the company I'm representing and have founded, we're starting in Switzerland, currently building our first production plant there, and then looking to rapidly extend internationally, expand to the US, potentially to Saudi, and then also to Asian countries. So if you're interested in discussing further, happy to do so. Thanks for approaching. Of course. I think I clicked something.
That's okay. Thank you very much, David. Very exciting technology and very exciting opportunity. We are going to have a fireside chat without the fire. So to join David and David, we have two more people to join the stage to lead this discussion. Prince Khaled bin Alwaleed bin Talal Al Saud will join us with Professor Mark Tester. Prince Khaled will lead a discussion with these experts on the role of plant-based protein in achieving food security in the kingdom. Prince Khaled is the founder and chief executive officer and founding chairman of KBW Ventures. As a figure of business, technology, and investor, Prince Khaled is a firm proponent of clean energy, healthy living, the humane treatment of animals, and a motivated voice for Middle East entrepreneurs. He invests in an array of successful but diverse global businesses with a focus of transformative technologies. Will you please join us on the stage? He is not joining us on the stage, he is joining us on the Zoom. And also joining us on the Zoom, I think, will be Mark Tester. Professor Mark Tester is Professor of Plant Science at KAUST. He is the Associate Director in the Centre for Desert Agriculture, which is the sponsor of one of the sponsors of this event. And he is the co-founder and Chief Scientific Officer of Red Sea Farms. So you there, Mark?
Yes, I'm here.
Yes, I can see you. So I will hand over to you, Prince Khaled, to take control of this fireside chat. Prince Khaled, are you there?
Yes.
Yes, I will hand over to you to take control of this fireside chat.
Okay. We can't hear you, Khaled. You might still be on mute. Oh, it's not so good. Tiny little crackle came through, that was all. Maybe I'll just kick off while Khaled's doing this. I'll just say quickly, my apologies for being remote, but I came down with COVID overnight. So I'm now at home for a week, and I hope everybody at the conference is healthy, that I didn't infect anybody. My sincerest apology, abject apologies if I have done. But yes, I'm going to have to just zoom in remotely. Khaled's back. No, still can't hear you. Okay. While you're working it out, I'll just keep filling in here. I'd also just like to thank David Welch. People probably don't realize, but the session started at 2:30 a.m. for him, which is pretty brutal. So thank you for coming.
My pleasure.
Food security actually does often focus on calories, and we've been focusing on that. How's your sound going, Khaled? No, it's still not working. Maybe take out your headphones and just go to your laptop. It's not working. That's a pity. I'll just keep doing an introduction. Food security often focuses on calories, and I'm as guilty as anybody for that. But actually, protein, lipids, micronutrients are also absolutely crucial. And that's really the focus, I think, of this session, is ensuring we have protein. And part of the driver for this is not just the inefficiency, the caloric inefficiencies of conversion of animals, as was highlighted by David Brandes, but also
hear me
the protein.
now?
Yes, we can.
Perfect.
Brilliant.
All right. Sorry
Brilliant.
about that.
Well done. Okay, I'll just finish my sentence and then hand over to you.
Sorry. Yeah, go ahead, Professor. Sorry.
No. I was just going to say, but the incredible thing, and Prince Khaled and I sort of discussed this ahead of time, I mean, is the incredible protein conversion inefficiency in the animal systems. And I think that's the primary focus, the cost and the protein conversion inefficiencies. So like beef, 3% protein conversion efficiency, it's spectacular. The best we can cope with in our agricultural systems are eggs, which are approximately 31% protein conversion efficiency. But I think we've got lots of opportunities and lots of possibilities for finding solutions to this and making huge contributions to reducing the environmental footprint of our protein production that we need in the world. So yeah, Khaled, you're at the forefront of this. You should kick this off and maybe even start by defining for us what we mean by alternative proteins, which I think was the title for this session.
Sure thing. All right. Bismillah, alhamdulillah, sallallahu ala rasulullah. Thank you very much, KAUST, for having me. David, I learn a lot from you always. So thank you very much for the great presentation that you had. Professor Mark, also thank you very much for this. I'm really honored to be part of this panel, and more importantly, I'm super excited and immensely proud to see Saudi Arabia on the forefront talking about these really important issues when it comes to alternative proteins, cellular agriculture, and one part of what is really affecting this planet in a negative way, which is obviously factory farming. So there are three types of protein production that I can think of that we've invested in the past 5 to 6 years right now. So it's precision fermentation, which is what Bond Pet Foods and Turtle Tree are doing spectacularly. One of them is really focused on the chicken side and the meat side. The other one is focused on the meat and chicken, but also really focused on the dairy side, which is something super important that I think we can really dive into in this session. Cellular agriculture, super important. We've seen about $5 billion in 2021 being poured into that technology. So I think there's a huge potential and huge growth we're seeing in the in this space. Obviously, we have Upside Foods, which is one of the most which is the leading company in my point of view, at least when it comes to cellular agriculture. Blue and Aloe, they're focused on fish, and obviously we have plant-based proteins, and we've seen the Possible Foods, and we've seen the Beyond Meats of the world. Those are the three types of technologies that are really leading the way. We've seen a huge push in the plant-based proteins market. However, right now we're seeing a huge amount of companies and investment come through when it comes to the cellular agriculture and precision fermentation, which are novel technology. Well, not necessarily novel technologies, but novel technologies when it comes to consumption for consumers. So these are technologies that we're really backing wholeheartedly, and to see Saudi Arabia in the forefront talking about these issues, and hopefully adopting some of these companies to come into Saudi and help us eliminate the issues that where we are going to be facing in the near future, in the near or far future, which is food security. As we all know, about 95% plus of the food that we consume here in Saudi is imported. So food security is a huge issue. I'm happy to see the UAE come tackle this issue with establishing a ministry, the Food Security Ministry. Obviously, it's merged right now with another ministry, but Her Excellency Maryam Mehri is a leading figure when it comes to these types of proteins and these types of technologies. And I'd love to see us being in the forefront even more, talking about it and acting on it more specifically.
So what barriers do you think what changes need to be made to facilitate the entry of alternative proteins into the kingdom?
I mean, honestly, the Saudi Food and Drug Administration will help a lot. The Ministry of Environment and Agriculture will be a huge impact for us in terms of us being an investor into these companies and bringing them over here to actually have some sort of establishment here in Saudi. So regulatory approval is going to be an absolute necessity. But swift regulatory approval, I think, is the key here. We've seen the U.S. Even though the U.S. leads in many aspects when it comes to establishing these companies, but they're lagging when it comes to having these companies produce these products and having them available for the consumer. The Food and Drug Administration, the U.S., the FDA, and the USDA are working very closely with a lot of our partner companies and other companies to start regulating these technologies. However, here I'd love to see that happen in a more efficient way. simply because if you really look at it from a technological standpoint and a practical standpoint and a necessity standpoint,
Yeah.
these technologies have to be established, and these companies have to have regulatory approval here to at least operate, and giving them the leeway, so to speak, to really develop these technologies even further, so that the price of these products can decrease dramatically, and hopefully we can reach price parity with the traditional meat, which will never be one-to-one, because we're talking about a heavily subsidized industry and a non-subsidized industry that's super important for the planet. So there is an inefficiency here, and there is an imbalance, so to speak. But I think regulatory approval needs to be at the forefront of these markets.
Yes, so we need things moving faster through the approval systems. It's pretty clear. So there aren't cultural barriers or those sorts of issues.
There are always going to be cultural barriers, and it won't be unique to Saudi. It'll be it's unique internationally. This is a new technology, a new concept. But at the end of the day, precision fermentation isn't anything new. This has been done for centuries. That's how cheese is made. That's how kombucha is made. Tofu is made. So there's a lot of consumption that people already are into, but they lack the education on what precision fermentation is. So the education aspect needs to ramp up, and I think that's also a part of the regulatory establishment, as well as the companies that are producing these products. So cultural is always going to be an issue, but it's not unique to this region. Sure.
So here's a question for all of you. I mean, that's good to hear, Khaled, thank you. But I guess price is key for a lot of this. We have animal proteins at I'm not exactly sure, $20 to $30 a kilo, in that sort of range, and we really do need to be able to bring the prices of these alternative protein sources down. People seem to be perfectly happy eating a lot of heavily processed food, so that's great. So we need prices. So all three of you talk among yourselves about how you see the prospects, I mean, as much as you are able, for these three different categories of protein sources that Khaled so well defined at the beginning. Maybe start with plant-based proteins and then go on to fermentation and then meat on a dish.
Yeah, I'm happy to start, Mark. I think, well, first of all, I would say I think we're already seeing the prices of these products come down. So just if you look at the US, for example, like the price of these more sort of innovative plant-based meat products like the Impossible Burger and Beyond Burger, we've seen those companies lower the prices multiple times over the past few years as they scale up. But I think that there's still a lot of opportunities to improve the way that we make these products, and lower the cost while improving the taste and nutrition. And I think where I see a lot of opportunities is actually outside of plant-based in this fermentation category that we've been talking about, because this has the potential to provide these ingredients that are provided at small percentages, like hemoglobin, that can dramatically change the flavor of these products. And I think that's where there's a lot of potential still to kind of, as I was talking about in my presentation, really push the boundaries of what's possible with these microbes to produce more and more of these proteins with, smaller amounts of feedstock or cheaper feedstocks, and really drive down the cost of these. And really, I think this is only just starting to happen now. So I think we'll start to see prices step down more and more over the coming years as this technology improves and we have more scale to produce more of these proteins.
And some of these raw materials are incredibly cheap, so theoretically it's easy to get the prices down extremely low. I mean, you mentioned CO2 and H2. Is that really going to be the best feedstock, or would it be better to have ammonium and starch or some other feedstock? I'm well out of my expertise here, but I'd really
Yeah, I think
appreciate input from all three of you.
I think it, and I'll hand it over to David and Prince Khaled after this, but I think it depends. So there's what we're just starting to unravel is the sort of breadth of microorganisms that we can use to produce these proteins. And I think that's what's so exciting is that you can pick different microbes that use different feedstocks depending on where your production facility is, right? You might, if you're building that in Saudi Arabia, you might want to use a microbe that uses a side stream or a waste stream that's very prevalent there versus some other region.
Yeah, that's a really good comment. Yeah, okay. David Brandes, do you want to add something? Press the side button so it goes green. Maybe his battery's gone flat. No, we're still not getting any pickup.
Keep talking, keep talking.
Ah, that's better. That's
Hello?
better.
Yeah, okay, I'm talking to the box. Look, so when it comes to fermented protein, it's really a game of the question of unit economics is a function of capacity. So you want to produce in large vessels and then energy, right? And both of that has a capex implication. So you can build those huge fermenters, those 200,000 liter fermenters, and then you can build solar panels, as mentioned before. And then you can bring actually in the case of biomass fermentation, where you use, for example, mycelial fungi and produce proteins, you can bring the cost of production down to parity and still have a 30 to 40% profit margin on that product. So I do think it's rather a problem of capex rather than opex in order to get to unit economics that make sense also from a consumer perspective.
Okay, that's a perfect segue to Prince Khaled, who not only lives the good life and talks about it, but literally puts his money where his mouth is there as a massive investor in this space. And actually should take huge credit, I think, for a lot of the growth of this space. Khaled.
Yeah, I do second everybody's opinion. I mean, I honestly can't add anything to what David and David already said, other than from my point of view, I see that the cellular agriculture side is going to be the biggest contributor to people who want to consume animal flesh, so to speak. Precision fermentation is definitely the way to go on the near future. And I think we can definitely see something happen on people's plates in fact in 2022. But for cellular agriculture, I really do. But if we're going to talk about cellular agriculture's price parity, well, again, we have to compare things apples to apples, and excuse the pun, but we're talking about a heavily subsidized industry. So price parity doesn't necessarily really mean price parity unless we're playing on a level and fair playing field. But nonetheless, even though we're not, the technology has gone down. The technology has advanced so far that the medium that these companies are using to feed these cells to grow has come down drastically. So what I envision, honestly, is we're already seeing a chicken on a plate in Singapore, and most likely we'll probably see it in Qatar very soon. But when it comes to on the shelves of retail, I honestly see 2023 being something that's going to happen, and it's advancing at a faster rate than expected. A lot of companies want to be conservative. A lot of companies will push back and say, no, that'll happen the next 3, 4, 5 years. I honestly see it in the next 18 to 24 months. We'll see some really advanced technologies and seeing these products on shelves within that time frame.
That's fantastic. That's extraordinary. What about the role of big players? I mean, like Danone. I mean, because a lot of this is entrepreneurial startup space. But what about the big established food companies, the Nestle's or Danone? I think Danone perhaps is a particularly progressive, massive company.
I'll leave it to David and David if they want to answer, and I can chime in at the end.
Okay, then David's.
Yeah, I mean, I think Danone, Mark, is a great example because they've already made acquisitions in this space. They've acquired several plant-based dairy companies. So I think that shows the sort of the trend that we're seeing is that most of these big companies, at least to date, are leaving the innovation to the more nimble and flexible startups, whether that's in plant-based or cellular agriculture, and then acquiring. And we've seen, for example, JBS, which is one of the world's biggest meat companies, they acquired a cellular agriculture company last year. So I think from my perspective, I think that makes sense. I've worked in big companies before, and things take more time, right, to kind of steer those big ships. And but there's so many. I mean, just looking at the sort of cultivated space, right? If we were talking 5-6 years ago, there were 10 companies maybe, and now you're talking about over 120 companies. So there's just a incredible growth in the amount of innovation that's happening in this space, and I think it's easier for the big incumbents to acquire that technology.
That's true.
Okay, but that's fine for some of these things. But David Brandes a minute ago was emphasizing economies of scale and the value of them. So then I'm thinking about, well, what about BP? Or I think they're moving in, aren't they, and doing a bit with CO2 and H2 feedstocks. I don't know if that's important to help get us over this hump that we're still sort of a little bit needing to get over. David Brandes, do you want to comment?
I mean, briefly on this, I do think there are, let's say, players of adjacent industries that are discovering synergies between what they've been doing historically and where opportunity might lie in the future. And those large players, for example, are, AB InBev, who has been fermenting a beer for hundreds of years. There is, ADM, for example, that is looking to also install bioprocessing capacity. You have players like Novozymes and others that come more from the biopharmaceutical industry and are also now understanding that actually the kind of knowledge, but also the infrastructure they have been developing in the past has now a new application within the food space. So I do think there is not only big ag and big CPG, but also big pharma now really waking up to the opportunity, and we'll see huge shifts in the years to come.
And of course, in China, you go there and they go, "What's the fuss? It's just a bunch of Californians making a lot of noise," because it's been plant-based proteins have been there for hundreds of years, and soy-based. Like texture vegetable protein. I remember being in a vegetarian restaurant in Beijing about 30 years ago and had a thing that was like a salmon. It was identical to a piece of salmon. It was unbelievable. So China's another whole space, I think, which I don't hear people talking about too much. Don't know if any of you want to throw in. Khaled.
No, you can hear me, right? Yeah.
Yes.
So no, China would be super interesting, and honestly, that's why we're seeing companies focus on China heavily when it comes to alternative proteins. We have our company, at least, Turtle Tree, focusing on there. We have Beyond Meat also focusing on Asia specifically, obviously China specifically. I mean, so it's definitely something that they're interested in. The issue with China obviously is the IP and the protection of the IP, and that's always going to be an issue. And we're seeing this develop and right in front of our eyes in the current few years, and specifically now. So that is a market that's definitely interesting for all these companies, but they have to enter it in a very careful fashion. So in my point of view, that will also drive price dramatically down. I mean, we're seeing huge companies such as Cargill, Tyson Foods, National Beef, and others. These companies are coming into these companies, investing in these companies, developing their own plant-based proteins and alternative proteins such as cellular agriculture. That they have the economy of scale to be able to distribute it in widely enough for the price to come down significantly. So again, the price parity is not necessarily the issue right now. It's just that getting regulators to in fact regulate this product, and then it's off to the races.
Regulators again, yes. Thank you very much, Prince Khaled. We've got time to open the floor for one question from the audience. Is anybody, this is spontaneous, I'm not sure this is planned, but are there anybody in the audience who want to ask questions? I mean, I'm very keen to see this moving into Saudi Arabia. I think it's a very significant potential contribution to food security.
Yeah, hello. First of all, thank you so much for the session. It's very interesting, and thank you so much for your efforts. I know the session is focused on the sustainability regards, but I would like to ask you, we know that meat is closely related to heart diseases and essentially heart diseases. So I wonder, these alternatives, how are they, like, are they better than these for human health, or are the same, or how it is in terms of human health?
That's an excellent question, diversifying the discussion. Thank you. Who would like to take this? Any of you? I know Prince Khaled would know, but David,
happy
David.
to start
David,
if you want.
Thank you.
I think the answer is it kind of depends. I think, and that's what's really exciting about these technologies, right? You can use something like cellular agriculture to make a piece of meat that is identical to conventional animal meat in every way, nutrition and taste. But because we're using flexible technology to make these, whether it's plant-based or cellular agriculture, you can adjust these. You can tune the fat profile of these. You can lower the cholesterol. So I think we might see, at least in cellular agriculture, that these first products, like the chicken product that's available in Singapore, are pretty similar in terms of their nutritional profile to chicken. But I think in the future, we'll start to see companies optimizing these technologies and really dialing in both the flavor and the nutrition. And I think that's what's so powerful about all of the technologies we've been speaking about.
Good. David Brandes, any final words?
No, I completely agree. I mean, I think wave one of those, let's say cellular agriculture products will be, to make them enticing to the consumer. That's more of a taste play. And then in the future, I think the wave two is definitely the optimization of the nutritional profile. You can completely modify the amino acid profile. You can, modify, reduce or increase. Sorry, wasn't here before. Well, you heard me. You can reduce or increase the fat content, saturated or unsaturated fats. You can tune those, so you can basically produce the protein and the nutrients in a very targeted fashion, versus having to rely on what the animal produces for you in an uncontrolled way. And on top of that, of course, you will also reduce the use of antibiotics. There will be no fecal contamination in the production process, because it's very controlled. So I do think that in a second generation of products, health will be a key focus.
That's great. Better for the planet and better for you. Prince Khaled, any last words?
I love that question, to be honest, and I think that's such an important. I think that's such an important topic. But the beauty of it is that I need you, whomever asked the question, and everyone else in the audience and everyone listening, to really just have an open mind to the fact that when you have milk, you're having milk that's also fortified with calcium. So you're having technology adding calcium to this type of milk. You're also having milk that you can add B12 to the milk, and I've seen these on cartons and everything. So that's not a new thing, that we're adding new features, so to speak, to consumer products. And that's the same thing that can happen right now with cellular agriculture. You can literally strip away the saturated fat and include omega-3s and omega-6s in there. So actually, someone can actually say meat is healthier now than it has been before. Nobody really can necessarily say that right now. So these type of technologies are not new. We're already adding fortified products and ingredients into these foods, and right now we're talking about adding them to the meats. So it's it's definitely an advance and definitely a welcome advance. And as David said, you're eliminating the hormones, you're eliminating the antibiotics, the fecal matter from these E. coli is going to be a thing of the past. So a lot of these issues can really literally be wiped out as soon as these technologies are adopted widely.
That's fantastic. Yes, and as David Brand has also said, we can control the composition. That's great. And we've been doing lots of additions to our foods for a long time. I mean, arguably iodization of salt was one of the greatest public health contributions, and the fluoriding of water. It's incredible
100%.
to public health. This has been a fantastic discussion. We haven't even mentioned methane emissions from ruminants, but it's been a wonderful discussion, and I've learned lots, and I hope the audience has learned lots, and I really genuinely, sincerely hope that this really can become part of the mix in improving food security, sustainable food security in the kingdom. This is a good start to a day where we're trying to seek solutions. I really sincerely think these alternative proteins are a very important part of this. So thank you all, both Davids and Prince Khaled, for your contributions, and thank you all, and I wish you all a very good day. Thank you.
Thank you.
Thank you. Get well soon.
Thanks.
Thank you, Prince, Khaled, and all of the participants. The potential solutions, such as plant-based proteins that were highlighted today, will feed into discussions tomorrow around delivery. So that's very important that we have had all of that information today. Our next session after morning tea will be specifically on plant science solutions. So how can plant science help solve some of these food security issues? But we are now heading into a break. Morning tea will be served in the lobby, just like yesterday, and we will reconvene at 11 a.m. So please be back in here and seated at 11 a.m. or online at 11 a.m. and we'll start our next session then.